The next type of microfluidic platform that we actually also find in commercial systems is based on the effect called electrowetting on dielectric, or Ewod. Yeah? The slide here explains how that works. Let us start considering we have a substrate, and on that substrate we put a thin but hydrophobic layer, typically Teflon, hydrophobic, and on top of that I put a water droplet. So of course my water droplet will not like, it's hydrophobic, it doesn't like my Teflon, so I will have a droplet that looks something like this. Spherical, but with a contact angle theta here larger than 90 degrees. Yeah. What can I do with that? Well, I can make a capacitance out of this. Because if this substrate here, if it is conductive, or if I put a conductive layer, for example, an electrode underneath here, I'm going to put an electrode, going to make that solid, black, so this is electrode. And if I consider my water being an electrode, so I put, for example, a wire here, and now I put a voltage difference between these two. If the voltage difference is 0, nothing happens. However, this is now actually a capacitor, because I have one plate of my capacitor and the other plate here is the water. The water is slightly conductive, so the water close to the surface here works as a capacitance, and this is the capacitance between this and this layer. This is a capacitive layer, and the Teflon is my dielectric. And what happens if I now put a voltage over this? I'm going to start putting charges here, for example, positive charges here, and negative charges here, and the system will try to minimize its energy, and it does that by increasing its capacitance. The higher, if I have a certain voltage, the larger the capacitance, the lower the voltage, the lower the energy the system will have. So how can it increase its capacitance? It will do that by trying to wet the surface. So the liquid will wet and wet and wet the surface until the droplet looks something like this. So the same volume of droplet will now be spread out and will now look like this. And now I have increased my capacitance with this amount of area here. So this area A1 and area A2 here. But what have I done? I have gone from a hydrophobic system with a high theta to a hydrophilic system, because by doing that I get a theta here, theta 2, that is not longer larger than 90 degrees, it's smaller than 90 degrees. Yeah. So basically, I can see that as the energy, minimizing the energy of a capacitance. I can also see it from a force perspective, is that if I put a voltage over here, I get positive charges and negative charges. They will attract each other, so these negative charges will attract the positive one, but also these ones. So I get a net force on this part here. So this charge here will want to move more and more towards this direction, and this one will want more and more to move to this direction. So my molecules are pulled towards the surface more and more. So from a force perspective, this is also a way I can see that. So anyway, the liquid will start wetting the system. So basically what I have is that if I have 0 voltage, it's hydrophobic. If I have a high voltage, it's hydrophilic. So by changing the voltage, I can switch my surface from hydrophobic to hydrophilic. And now you can do really cool stuff with that. The first example, maybe I can draw that out here, is if I have 2 electrodes next to each other. This is a cross-sectional view. Now I'm making a top view. Yeah? So I have a top view of 2 electrodes. They're not touching each other. They're next to each other. And I put a liquid droplet that's sitting here. This is a top view of my liquid droplet. So I'm now watching from this side here, top down. I see my liquid droplet on top of one of the electrodes. If I do nothing, this system will be hydrophobic. Now what I can do is make 1 voltage here and connect this to the droplet on the top. So if I put my voltage source here now, what's going to happen is that this liquid will now start being attracted to this electrode, and this droplet will, instead of being hydrophobic here, it will become hydrophilic here, and the droplet will move from here to here. Yeah? And if I take away the voltage and now make couple, instead of coupling the voltage between now the droplet and this electrode, I can structure my liquid back. So depending on which electrode I'm going to put my voltage on and where not, I can decide which of these patches become hydrophilic and hydrophobic. So if I make a path, for example, as long as this is hydrophilic, the liquid will be here. If I make this one hydrophobic and this hydrophilic, the liquid will move here. So I can move my droplet between these two positions. And I can do more. I not only can move it, for example, in this picture that you have in your slides here, I split my droplet. So at first I have it in the middle here, and then I split it by pulling it to two sides at the same time until it splits in two separate droplets here. You can see that here. And here I remove the voltage and I will recombine my droplet here and it will go back to its original state. So I can split droplets and move them up and down. And now we can do really cool stuff. So we're going to see some really cool examples of that in the next 3 videos. There's 3 videos that I have added. They're all 3 from commercial or semi-commercial devices. The first is a plate, a system where you have a lot of these little checkerboard electrodes one next to the other, and then you can start moving little droplets all over the electrode from wherever you want it. And they're using that in this video for doing DNA analysis. So you see little colored droplets moving around, and each has a specific biomolecule, and they put biomolecules together by merging droplets and splitting them. You can do chemical reactions and moving things to the waste, etc. The second video you're going to watch is that of a variable lens, because you can consider now also this liquid droplet to be a lens, you know. And if I shine light, for example, in this direction, you can see this lens will be more spherical than this one. So I can control liquids as lenses. And you actually, I think this is commercially available in a number of mobile telephones. So the lens in your mobile telephone, not in all, but in some, I believe, are made out of this kind of droplets that are changing shape using electrostatics. So there are commercial lenses that use Ewod for changing the focal depth. The third system is a system from a company called Liqua Vista in the Netherlands, and there they try to make entire displays where they use little colored droplets, move them in front of no, they have colored light, and then they have little black droplets that they either move in front of a colored light or not. And doing that, they can change which color comes out, and so they can make an entire display like something like an iPad screen, but entirely using little droplets and making really a color screen. And that's the third video that you're going to watch. So enjoy that.